Hello, everyone. Welcome to the From Zero to Hero FieldView Basics webinar. We'll be going through some very basic workflows in FieldView. So if you're a new user, this is going to be very valuable to you. But also if you're a seasoned user of FieldView, we think you're going to pick up some tips and tricks here. So we're excited to do this for you. We will be going through this at a slower pace, so hopefully you could follow through. But don't worry if you miss something. We will have a recording available that you could go through these things more slowly, and if your colleagues are interested, you could pass this along to them as well. So we're going to do that. So with that, next slide, please, Marie. So just to introduce ourselves, on the right, my name is Raja Alimuthu. I'll be the moderator today. And I am your daily account representative. So if you need anything, after this webinar, if you're interested in getting an evaluation of FieldView, if you have any questions, please contact me directly. We've been having some, these webinars are good to get some general information out, but we found it very valuable to have one-on-one conversations with our customers. So that's the reason you've seen emails from me trying to set those conversations up. We'd love to, after this, to have more of a deep dive conversation with you on how you're using FieldView, how maybe talk to you about, future requests that you have or better ways you want to use FieldView. So we're always happy to set that up, and I'm happy to coordinate those. On the left, we have Yves-Marie Lefebvre, and he will be doing most of the heavy lifting for this webinar. As you know, he's now acting as the Chief Technology Officer for the whole TechPlot umbrella. As you know, TechPlot purchased FieldView in 2019. We are still operating as separate products, but we're under the same umbrella. So Yves-Marie is now in the role of CTO as for the whole TechPlot umbrella, but he is still the FieldView, the main FieldView product manager representative. And so he'll be doing most of the heavy lifting. And again, for some of these deep dive conversations, I could bring him into the conversation about if you want to talk about your workflows more in depth, we could definitely have that. So,
all right. Hello, everyone, and thank you, Raja, for the introduction. I'm glad to be with you here today to give you a quick tour of FieldView. Before we start and dive into the demonstrations, just a quick word in case you're not familiar with the software. So FieldView comes from mainly the US aerospace industry. It has been developed by a company called Intelligent Light, based in New Jersey. This is still where all FieldView Development Task Force is based. And as you mentioned, Raja, we joined the TechPlot family of products in 2019. So we are part of the same group, and further along the way, we merged the two companies. So TechPlot is really the name of the company under which we have multiple products, two of them being CFD post-processors, 360 and FieldView. And we also have the products like TechPlot Chorus, TechPlot ARS, which is specifically for the oil and gas industry. So that's basically what we do. So we are now a stronger organization supporting and maintaining both TechPlot 360 and FieldView. So today we are going to go through mostly demonstrations. After these quick introduction, I'll be done with slides. What I want to do is go into our software and show you how you can very quickly load your data and create some scenes, create some images, videos that are going to allow you to both understand your results and also communicate these results to either your customers or your management. And I'll try to do that in a way that has several layers, that will be easy to follow for people who are totally new to FieldView, but also provide some valuable tips and tricks for our more seasoned customers. So with that, with no further ado, let's go and work from FieldView and load the first case for our demonstration. So for loading data, you need to go to File, Data Input, where you have all of our readers listed. And what we'll do first is load a case that has been exported from a commercial solver to the FieldView format. So I'll read a combined grid and results file. All right, I'll grab this one over here. You can see that we have two files with almost the same name. It's just a time step that is ending differently. So FieldView will recognize that. It is scanning the rest of the directory. And it will, after a few seconds, ask me whether I want to read that as unsteady. So depending on what you want to do, in this case today, we're not going to use the two time steps, so I'll just say no. And FieldView right there has just loaded a 12 million sales case on my laptop. So I can close this, and what you're seeing now is what we call the outline, which is really the outside of each of the blocks that makes the grid that we are working with. So if you're not interested into that, you can turn it off by toggling the outline over here. So next, we'll want to create some objects to look at. And all of these post-processing objects are listed in the toolbar on the left over here with some icons that speaks for themselves. You got ISO surfaces over here, streamlines, particle paths, coordinate surfaces, and so on. And you also have access to the same through the visualization panel menu over here. So typically the first thing you want to do after you've loaded your data is to look at your geometry. So we'll hit the bound button for opening the boundary surface panel. Next thing you want to do is create a surface. Until you've done that, nothing is enabled over here. And you'll see that the rationale behind the design of each one of these panels is that they're going to be very similar from type of surface to type of surface. So you'll be familiar with this layout very quickly. So I'll start by creating one surface, and that gives me a list of all of the boundary conditions I had in my solver. And that list can typically be very long. People sometimes use very long naming conventions to recognize different parts of their design. So what we did was to include a filter over here. And so for instance, here, I know I'm working with a plane geometry. So if I type in the word plane, it's filtering out only the elements in the list that have plane in their name. So once I've filtered that out, I can do select all, okay. And if I center the view, I'm getting my plane. By default, it is in mesh view. So I'll change that to smooth to get a shaded view of my aircraft. Next, we'll create a second surface. You can see that I'm missing a part of the aircraft over here. I'm missing the propeller. So same steps, create, I get number 2. Now for the propeller, we'll type in prop, select everything, and hit OK. And if I do that, you can see that I'm also grabbing portion of the mesh. We have a rotating grid over here around the propeller, and I don't want to look at those interfaces. So I'll select them out, hit OK to refresh. And just like that, I have the geometry that I'll be working with. So next step is that I want to look at the variables on that object. So I'll go back to surface number 1, and we'll change from geometric coloring to scalar coloring. But before I do that, I want to pick the right scalar. So that's the list of all the scalars that are either included from, derived from the geometry, or with the variables that have been exported from the solver. So we'll look at static pressure as a starting point. And when I select scalar over here, it gets colored by static pressure. Now, pressure is sometimes a bit tricky. So if I move to the color map tab over here, it can be tricky to adjust the min and max. Maybe you know exactly what you want, but even if I hit local in this case, yeah, that's going to help a bit. But minimum and maximum pressure are always going to be on the geometry. So entering in some values can help a bit more. So what I'll do is typing a minimum of -5 to power of 3, okay. And you can see that I'm still getting a lot of green because of the color maps that I'm using. So what we often recommend is to move away from the very traditional spectrum color map, which is not doing a great job at discriminating what is happening in the middle range of your variable. So if I go ahead and pick another color map, say this one over here, achromatic vision, all of a sudden you can see a lot more things happening on the wing, for instance. So here a quick tip for our advanced users. If there's a color map in this list that you like a lot and would like to make your default color map, there's a way to do that in FieldView. And I'll show you how you can identify this. So FieldView has a lot of doc, very powerful if you know what you look for. So in this case, I'm looking for the color map files, and from the working with FieldView over here, I'm finding the instructions for where to customize the color maps that will show up at the top of the list. So basically all I need to do is copy a color map file at my user directory in a given location, and FieldView will pick it up at startup. So it means I will be at the top over here where it says user, and because it's at the top, that will be my new default color map if you want to stop using Spectrum as a default. All right, next you can see that here we have Scala colored aircraft, but the propeller is still gray. So I could go and do the same thing manually on the propeller, or I can hit the Unify button over here, which is going to apply the same settings to all surfaces of the same nature. Okay, that's done. And yeah, the pressure is on the suction side, obviously very low on the propeller. So what we'll do is change the background color to white so that the propeller becomes visible again. Okay, now we're doing engineering, so we want more than colors. We want to be able to understand what those colors correspond to. So what we'll do next is add a legend. So I just have to do show legend and adjust the font colors over here since I'm working on a white background. I have a number of options. For instance, with this kind of aspect ratio, I like to make it an horizontal legend because I have some room at the top and at the bottom. This green box over here is text only, right? It's telling me how to control the legend. It says shift left mouse for moving around and shift right mouse for resizing. So we'll make it bigger, put it at the bottom. I also want to adjust the number of decimal places. I'll have a few labels. You can see that you have full controls over what your legend will look like. Okay, so after just a few minutes, we are done here adjusting our image. So let's say that I want to include that into a presentation. What I can do is go to Edit, copy my graphics. And if I come back to my PowerPoint over here, I can just copy that in my slide. If instead you want to save it for later use, I can go here, File, Save Image, Graphics, and then I can select the image format that I want to use. All right, moving on, then we'll go and work with a second type of object. Before I do that, I want to set back my coloring to geometric to simplify the view a bit, and I'll use the same trick, Unify, to do it for the second boundary surface. And we'll move on to cutting planes that are called coordinate surfaces in FieldView. So it's just the same idea. I need to hit the Create button to get my first surface. So by default, I'm getting an x = 0 plane. And what we'll do is change it to constant. And we'll look at velocity magnitude on it. Okay, so let's go to the color map tab. Same trick over here. We want to change color map to move away from spectrum. So you have a number of options over here. I really like the one called Inferno, Magma, and Plasma and Viridius, because they are diverging color maps with variation not only in color but also in luminance, which gives you really more depth as you work with it. Okay, so let's lower the max value a bit. And here all of a sudden you can see the propeller wick and how it's interacting with the aircraft if you have the right range. So going back to the main surface tab, FieldView makes it very easy to shift the direction of your plane from X to Y or Z, okay? And very easy as well to change the location of the plane. So let's zoom out a bit. Okay, so you can use a slider or you can type in a value. And what we'll do next is reduce a bit the extent of that cut plane. So I can, again, either grab a slider, okay, or type in a value if I wanted something to be more accurate. So we'll go from -6 to 6, and we'll do the same for Y. Let's go from -2 to 2, for instance. Okay. So from that stage, it's quite easy to let's adjust the values. Yeah, if we go from this point at the back to this point at the front, okay, and just the number of steps, we'll make it 50. And right there, I can sweep the location of that plane. So that may get a bit choppy going through GoToMeeting, but on my screen over here, it's just changing position very, very quickly. I have a live animation. So let's stop for a second and start again from the top. And what we'll do is record that into a video. For that, I go to Tools, Flipbook Build Mode. That's our name for the simplest video you can do in FieldView. And now the sweep button became a build button. So I just have to hit it and FieldView will loop through 98 steps in this case. So that's cached into the memory. And when it's done, I can write a video. So by default, we go to MP4. I can define the frame rates that I'll put in that video as well. So you can see that very quickly, we can create pictures and videos of the work we are doing. Okay, so from that point, I can make multiple surfaces maybe if I want to look at the object, if I want to look at the flow field in different areas. So I can make surface number 2, move the slider, make surface number 3, move the slider. Okay, and so you can have slices through your data set like that. Or if I go back over here and let's get rid of this one and this one as well. And by the way, what I'm using over here is what we call quick pick. So quick pick is you double click on the surface and that makes it the current surface and brings up its panel. So I've just double clicked on the wings that gave me the aircraft. I'm now going to double click on that plane and it gives me the coordinate surface panel and I'll delete it. Okay. Now I'm going to hit create again to create a second surface at the same spot. And I didn't mention it, but you can see that all the surface properties get applied to the new object, right? The new object inherits all the properties from the first object. So now that I have that, I want to show you a quick trick. Let's say that I want to have a better look at that cut. So I want to move it to the side. You can go over here to Object World, change it to Surface, and move that surface away. Okay, so once you've done that, really what we want to do is put it flat to screen. So we'll do +Z, okay, move it away, hit detach. Okay. And now if I go back to Object World, the rest of the world is moving with that cut plane. So let's take it a step further, but before I do that, I want to turn off perspective. So I go to View, turn of perspective, and adjust the zoom level a bit. Okay. Now, if I go to Tools, Linked Surface Sweep, the two surfaces are now linked together. So if I hit the sweep button again, they are sweeping at the same time. So I have one showing me the surface location on the plane over here, and I have another flat to screen view where I can really see what is happening on my cut plane. Okay, let's get rid of the one I have on the side over here, and I'll show you another way to do something a bit similar, this time working with multiple windows. So FieldView has the ability to cut that graphic window, and as you do so, you can define what you're putting in that new window. So it's made with those buttons over here that show you the direction of the split. So we're going to split vertically. And I'll start with the instance. In a second, I'll show you copy and empty. I guess that's easy enough to understand what it does. It opens an empty window, and then later on, you'll be able to append data to it. So we'll do an instance. And the idea of the instance is that we have the same objects in both graphics window. Okay, if I come back over here and change the slice position, it's going to adjust in all of my views. So what it does for me is really, it's very helpful for having different views in different windows. So for changing the view, I need to desynchronize the transforms. And now I'm transforming separately one of the windows. So what I can do is align this one along, say, plus Z, and then I'll create another split instance again. And this one will do from the top, which is plus Y. Okay, so what we need to do then is create another surface for it to be interesting. We'll make it plus Y. Okay, and coming back over here, I can use those buttons to line up the aircraft so that it's facing right. Okay, all right, zoom out a bit. And I can align them and maybe make a bit more room for what we have here at the bottom. Okay, so with these multi-window instances, as you saw, it's very easy to compose the view where you have different view angles on your simulation. I should save that image. If I go back to copy over here, now I have two options. Window will copy only what I have in one of the windows, the current one. But if I do copy graphics, it's just going to grab everything, and I can copy paste it over here. So you can see that you get the combination of all of your windows. And finally, yeah, as we're working on these multiple windows, just want to show you that I can maximize one of them to go back to work on the first one that I had. I can bring back the other ones, or I can close them to simplify the view and be back to working to that point of a single one. All right, let's just keep one coordinate surface. This time I'll make it visible instead of deleting it. And we'll move on to working with ISO surfaces. So same idea, I call the ISO surface panel. I need to create my first ISO surface, and for the ISO function, we'll pick vorticity magnitude. Okay, it took a second to compute, but I'm at a current value that doesn't make much sense for vorticity. I'll make some adjustments before we use a better value. Okay, let's go for, let's say 400. Okay. Well, that's probably a bit too much. We are not seeing the wake from the propeller that much. So I'll come down to 200. Okay. And yeah, that's much better. But you can see that because we are looking at vorticity, we also get a lot of zones being highlighted close to the aircraft geometry. So it's hard with vorticity to differentiate what's coming from shedding and what's coming from rotation. So what we can do instead is make an ISO surface of a more discriminant factor, and FieldView offers two natively. So what we'll do is create a split again. This time we'll go for copy. So what copy does is that it's creating in memory an actual copy of the data set that I'm working with. That will then allow me to do different things on the two windows. So what we'll do is that at the top, we'll keep the ISO surface of vorticity. And at the bottom, instead, I want to look at the different ISO. So I need to create a function first. So we'll go to the function specification panel, create a new variable. And we have over here two that are very useful for looking at vortices. We have qcriterion and we have lambda2. So let's use qcriterion for today. And the function only expects one input, that is the name of your velocity vector, which is different depending on the solvers that you have. So that's why you still have to select it. Okay, so we'll do q based on the velocity vector and use the formula for the name. So now that I've done that, I come here, work on this ISO surface, and I'll change the ISO surface function. And you can see that Q criterion based on velocity is now listed over here. So I'll select that. And so Q is going to be calculated one first time, and then an initial surface is going to be computed. And because the value is very, very small, nothing shows up. When you work with Q, what you want to look at is positive values that then highlights areas where rotation is dominating the flow compared to shedding. So what you need to do really is start from pretty high values. Let's do 1 to the power of 5, for instance. I'll see what we get. And then what I recommend is that you gradually come down by orders of magnitude. Okay, and yeah, that's 10,000 is already a pretty good value. And you can see that we are catching the propellers wag just as much, but we are being much more discriminant in areas around the aircraft over here. And now what is nice with these multiple windows is that if I keep the views synchronized like this, I can change the view on all surfaces and continue to do that comparison even when I zoom in and surfaces don't get on top of each other. Okay, so that's for the ISO. Let's move on to show you how to work with Streamline. So for doing that, I will close that window. Let's clarify the view a bit by turning off the visibility of our ISO surface. And we'll work on Streamlines. And by now, you probably understood that you have the Create button in the upper left corner of the panel. First thing you need to do is hit it. And next, with Streamlines, the important step is to position some seeds from which the lines are going to be computed. So in this case here, what we'll do is that I will use a propeller to put some seeds. And we have different modes, and one that I like is called add between. So it's going to add seeds between the beginning and end defined by of a segment defined by my 2 points. So I pick them point number 2, then point number 1. We can adjust the number of seeds, say 15, that will be positioned in between. And we want the streamlines to be computed in both directions. When I'm done, I can hit calculate. And FieldView computes the streamlines going across my data set. You can see it's been quite fast. That's one of the things we use multi-threading for to speed up this computation. So once that's done, I can adjust scalar coloring, let's say velocity magnitude. I can pick a different display type. We'll do spheres. Increase the number of spheres, get rid of the seeds, and that can be easily animated. And it makes some pretty nice animation if I pick the right view angle. Again, that might be a bit choppy going through GoToMeeting, but very nice when you do it on screen. That scene is rendered on the graphic card, and the graphic card is doing all the job over here. So the refresh rate is very high. Okay, so that's for Streamlines. quick introduction about them. I'll stop the animation, turn off their visibility. And for the last segment of that first demonstration, what we'll do is come back to work on our boundary surfaces. So FieldView has a third mode for rendering boundary surfaces on top of geometric and scalar. We have something we call material. And so material is going to give you different effects on the object that replicates different material that you find in your geometries. So I'll go and pick material. You can see that by default over here, it went for the first one, which is aluminum. So let's zoom in a bit more on it. Yeah, and I should mention that by default, if you've never changed it, this is the environment map that we use, which is more generic. So let's start with that. So if I pick a different material, it updates automatically. You can see that we have gold, iron, titanium, for instance. What I'll do is stick to aluminum. And I'll come back to a better suited environment for an aircraft. So we have some that are better for cars. We've got a street, we've got the sky. So this one is good with clouds. It works very well for an aircraft. And what I want to do next is show you how you can select the center of rotation. So that's one for advanced users. If I go over here, set center of rotation, you can see that my cursor has changed. And I need to do Control-click on an object. And now the view is rotating around that particular point. Now you can see that the clouds are being reflected in my object, which gives me a very good feeling of a metallic part. Now what I just did here by changing the center of rotation, it can be canceled by just recentering the view. And now the center of rotation is in the middle of the view again. And that means that it's also a trick you can use for centering the view on a given object, okay? So if I'm over here and I get rid of the plane and center the view, the center of rotation is going to be around the propeller, even if I bring back the plane. So that's here another way of controlling the center of rotation by using this center view button. All right, let's recenter everything. Now what I want to do is go over my aircraft and give it a more realistic rendering for all the various parts that make it. So here, the rest of the aircraft, I could make it a matte paint. For instance, I still need to activate material rendering, okay. And that one allows me to control the color that I apply to it to the matte paint. So we'll do something a bit greener, maybe a bit more camouflage. Okay, and now if I want to go further, you can see that I will have to decompose the boundary surface based on all the boundary conditions, all the patches that I've been receiving from the CAD. So it's pretty simple. You just have to go over here in the list and type in the code names that you have for them. But that will take 7 minutes. So you understand the logic. What I'll do instead is load a restart that I've prepared, where the surface is broken down into its components. So I'll go over here, open restart, and open the works that I've done earlier. So it's not rereading the data, it's just reordering my boundary surfaces, and you can see that I have 5 now. So what we'll do is put a material, let's say titanium on the propeller. The aircraft will be matte paint. Okay, here we have all these metallic parts. Aluminium will be good. And finally, canopy will activate glass over here. Okay, and maybe a bit less transparency. Okay, now we have a much better looking aircraft. Maybe this is too chromy, and yeah, let's change it to aluminum instead. Okay, and now that we've done that, the next step for making our image even pop up a bit more is to use an image as a background. So you can put in any image you want. We accept all the typical image formats. So here I've got one of a sky with clouds. I just need to hit use image. And I can stretch it so that it takes the entire space on my graphics window. And you can see that here I have a very nice match between the environment maps that we use for all materials and what I have in the background. Now let's bring back some of the objects that we were working with. Yeah, maybe I'll make that Z surface. That's not what I wanted. An X surface is better. Add some transparency to it. Okay, bring back the streamlines. Okay, put some ribbons and shading on the ribbons by calling presentation rendering. Okay. Yeah, right there we have our component image with all the elements working together, and we have both the engineering results and the nice rendering and the environment that give a bit of context to the results that I'm working with. Before I conclude this first segment of the demonstration, I want to show you how you can save this work beyond just saving the results with images. You want to go over here, File, Save Restart. I will save a complete restart that we'll call, yeah, webinar. I will overwrite that. And right there, we've saved the work so that we can pick up the session at a later time at the same point, or also have bricks of workflows that we can reuse for other data sets. Okay, Raja, do we already have questions at this stage that you'd like me to handle?
Yeah, we have a few here. So are you ready to ask you some questions here, Marie?
Well, if you see a good fit, what I'd like to do next is reread the same case, this time in parallel, to show the performance improvement. And we mentioned the fact that there's a lot more in FieldView that we'll be able to show, but maybe I'll have the time to show you how to create some extracts and do a tiny bit of scripting.
Yeah.
So up to you.
Let's go through these questions because I think these are pretty good. Let's get these questions done now. Is it okay?
Okay.
All right. So the first question is, can you demonstrate how to create surface streamlines using surface skin friction vectors?
Yes, but I don't have this vector in this data set. I'll give it a try based on the velocity. All right. So let me simplify the view here. And so friction lines can be found in FieldView in the vortex score panel. It's called actually in full vortex score surface flow, which is our name for friction lines. So same idea, you need to create your friction lines. If you already have the friction as a vector from your simulation, you'll want to use earlier and set it as input vector. I don't have it in this case. I only have velocity, so I'll do no slip and make sure that velocity is my current vector. And FieldView will automatically compute the gradient of velocity at the wall, and that will give me the friction based on which I'm going to establish my friction lines. So let's hit calculate. Again, this is another computation where FieldView uses multiple threads. You can see that the default density is pretty low. We do it deliberately because that computation can take some time. So here I can crank it up to medium and run it again, and we'll get more friction lines. All right, let me change them from gray to black. Yep, that works pretty well. And here you can see our friction line with some rotation being used by the propeller, and also you can see the different aspects of the flow. We're not running a very accurate simulation, and we don't have a high angle of attack in this case, so you're not catching separation on the wings, for instance, but that will show up with such friction lines. All right, hopefully that answers the question.
Yeah, and again, if you have additional, please put that in the question dialog, but we'll also follow up with that user directly as well. So thanks, Eva Marie. So next question, is it possible to generate an arbitrary plane, just not necessarily just an XYZ, but an arbitrary plane instead?
Yeah. Great question, something I haven't shown yet. So it's just that you will not find them in coordinate surfaces. Coordinate surfaces just for XYZ. So we put them under ISO surfaces because to us really it's an ISO surface of a plane function. So we'll go over here and you can see that, yeah, all right, so let's create a second one. I want to keep my ISO surface. And you can see here it says cutting plane. So that's where you want to go. And we have several modes for defining the plane orientation. You can do 3 points, for instance. So let's say that I want to pick these 3 points. Okay, and that's going to calculate a cut through the data. Okay, so it shows me my 3 points. And yeah, I picked close, sorry about that. That was oh no, okay. The visibility was off. Here we go. So here we have our cut, and let's show something more interesting on it. So yeah, so we have velocity on the cut, and let's add transparency here. So now that we've created that cut, we actually have access to all the cuts parallel to it. Okay, as we do that. So again, if we go back to the cutting plane here, you have different options for defining that plane. So 3 points. You may have their coordinates if you want to type them in. Another one that is nice is the normal vector. So that's based on 2 points. Or you can just do parallel to screen. So if you have an orientation that you are interested into, you do parallel to screen here. And that will give me an arbitrary cut plane. Okay, so let's go back to number 2 and turn it off. There we go, and this is our third plane over here that we are working with. And again, I can use the slider to define another location for that plane. I'm not on the right one. Okay, now I'm changing the location for plane 3. Okay. You have any other question, Raja?
Yeah, just real quick, just how to bring that sky background in, just to go over that one more time.
Yep. Yeah. Sorry, I realize sometimes I get a bit ahead of myself and go too fast. So as Raja mentioned, the recording will be made available, so we'll be able to play back. If there are things that you didn't catch up, you'll be able to get back to them at your own pace. So it is over here in View, Background Environment. I can select the image I want from here, and I say use image or not. And the other trick is how you want to fit or stretch to the extent of your graphic window. This one is very handy. You can also do something more serious. Maybe you want to have a gradient that is easy to define in PowerPoint, and maybe you want to have a logo of your company, in one of the corners as a watermark. All of that can be done with an image in the background.
Thanks, Eva Marie. Yeah, sorry about the interruption, but I thought those are important questions.
Yeah,
so
those, excellent questions. Excellent questions. Yeah.
Feel free to continue with the presentation.
Okay, that's it for now. All right. So yeah, what did I want to do next? Yes, I want to. So when I started the demonstration, I went straight ahead and loaded the case with my default settings. So I've been using serial over here. If you want to use more cores for reading the data faster and doing other operations faster, There's one more step you need to do, so I do want to show you that. You go to File, Data Input, Local License Parallel. So for most of our licenses, it will give you access to up to 8 cores in MPI for reading your data. And if you have more cores available and want to get more speed up, we also have options for letting you run on more cores. So I'll do that, File, Data Input. If I come back over here, you can see that now it says Local License Parallel. And we're just going to reread the same case. So I'm in replace mode, so it's going to replace the one I have currently in memory. And okay, so I'm just looking for the same file. It's over here, the heaviness one. And okay, before I do that, let's see if I can show you. It's not a super large data set, but at least I want to show you that all CPUs will be used for reading the case. Okay, so that was pretty short, but you can see a peak over here of 100 CPU, all the CPUs working at the same time. And maybe you've noticed that it was a lot faster for it to apply the, to load the case. From that point, if I want to call back the works that I've done, but without reading the data, because how I read it has been saved in the file. So if I do that, it will be reread in serial. Instead, I want to do complete and not read data, do data read. Okay, and that's our restart over here. And so all of the objects that we had created together are going to be called back. And yeah, so the performance is also faster because, as you can tell, all these CPUs have been working on it at the same time, especially for the large ISO surfaces. And we're still using multi-threading for the things that benefit from that type of parallelization for performance. So we have an hybrid parallelization, really, both multi-threading and MPI. So that's for parallel. For most of the solvers that do export to the FieldView heavy-units format, the partitions from the solver are preserved. Sometimes you have to be aware of how to do it. So if you have any doubt, please don't hesitate to come to our support team or ask Raja or myself for how to do that. And for a lot of the structured format as well, we have options for using the multiple grids for parallelizing our operations. So if you're not already doing so, I encourage you to always use parallel because I will give you great speedups. And here I'm only covering the local use of parallel, but you also have the option to use a server. If your data is sitting on another system and you want to use multiple cores on that system for reading your data, like an HPC cluster, for instance, that can totally be done. It's a bit out of scope for this basic webinar, but we have material to explain how to do that, and our support team is always happy to help you with that as well. Raja, if you don't have any more questions, maybe I can show you very quickly the main ideas for automating that type of work, or maybe you want to go through extracts first.
Either way, more questions from the, so there's one more user question that came in. Is FieldView capable of working with large data sets?
Yeah, it is very capable. It is also very savvy on the, it doesn't use a lot of memory. So that will allow you to read some very large cases compared to competition. So yeah, the only limitation is the amount of memory you have on your system. But this is really one of the first motivations for people to use FieldView. It is fast and capable of working with large datasets. All right, so in that next step, what we'll do next is and the streamlines as well. Okay, so we have the plane here, we have that cut plane or coordinate surface. What I want to show you is the trick we have in FieldView where we can export these objects to another format that we call XDB. So we'll do viewer XDB write, okay? And I'll call it, let's call it webinar. Okay, not very original. Yes, and then I can pick what variables I'm going to put in that export. So I'll just do velocity magnitude. I'll say, yes, I want to maintain the threshold I have on my surface because I want it to be as small as possible. Here we go. So FieldView is writing that. So remember that we're dealing with a case that is about 12 million cells, 1 gigabyte more or less on disk. And so let's see what we've obtained. Before I load it, I want to create an empty window over here. This is where I'll put what I've just exported to not touch what I have in my session over here at the top. Okay, so from the bottom, we'll do file. For the format we've just used, we want to read it in serial because that's a small case. Okay, and this is the import for the format we've just exported. Again, it's called XDB. Go and load that and just want to show you, yeah, so the file we just created together, webinar.xdb, is just above 20 megabytes compared to 1 gigabyte again. So that makes it super easy to work with. You will see that it gets loaded instantaneously. And it also means that it's very easy to archive or share with others in your team if they want to look at a portion of your results. And then all the surfaces that I have on the top, at the bottom, they're going to come up as boundary surfaces. So here I have all of my aircraft. Okay. So you can see that I didn't start from the same view. So what we'll do is open a view, restart at the bottom. Or yeah, even easier, we'll do a reset. Okay, that's better for synchronizing the views. And so over here I have, yeah, the velocity magnitude, that's not a very good pick. Yeah, I should have exported pressure as well. But if I create a second surface for my cut, on that one, I can look at velocity. And if I pick the same color map and adjust the range. So again, with a much smaller file, we have the same information. There's no reinterpolation. It's just that we kept only what we needed around that aircraft to make a 20 meg file that can be shared with anyone and loaded on a much smaller system. Let's say that you're traveling to visit a customer. You want to show a portion of the results. You could use that file instead. Okay, and so one more thing before we get at the end of our time box. Let's get to scripting a tiny bit. So FieldView has support for scripting languages that will allow you to do everything that we've done together here, but automatically through our scripting language. And the best way to get into it is to do what I did before when I saved the complete restart. So let's go move to the directory where I created those restarts. Okay, so they're called webinar, and so that's really a set of files that have been saved automatically by FieldView. And one of them is called FVX, which is the name of our scripting language. So if I open that in the text editor, you can see it's pretty simple syntax. For instance, we're calling a function here for reading a data set. And basically what we provide as inputs is where to find that data set and what is its format. So that's quite simple. So you don't need to look at all of that for now. I'll just get rid of some stuff at the bottom that is just for printing information if I re-execute that script. That's not necessary here. And what we'll do is just use that backbone of a script to add more things to it. For instance, if I want to run that script, which is going to load my case and create all the surfaces, and say that I want to save an image at the end, it's a one-line command. So I call fv script. Then I pass in an argument, which is a command for printing. So I'll do print graphics PNG, and we'll call it webinar image. So that's one line for saving an image in batch. Next, let's say that I want to do the same export of my XDB file that I did interactively. Maybe you want to do that reduction of the size of your data on your cluster before you transfer your results. I can do that as well. So the function is called XDB view, and we'll reuse the same name for the XDB file. Okay, well, maybe webinar 2, so that we see we have a second XDB file. So I'll just overwrite that file. And from FieldView over here, let's get rid of one window, and we'll test that script interactively. I will execute the file that we just saved together. And so that's going to go through that file. So again, load the case over here at the bottom, create the isosurface, create the boundary surface, create the coordinate surfaces, the streamlines. It's redoing everything based on all the input that has been saved automatically to that file, and it's going to execute those commands at the end. Okay, and so yeah, I made a small error in my. Yeah, I said I was typing XDB right, but I typed XDB view, which obviously is not what I wanted. So over here, we'll just save that. And yep, there was an error. Sorry for my typo. So I'll just re-execute the script. And yeah, we'll let it run as I get back to you to see if we have more questions. Last round, maybe you want to answer before the end of this webinar, Raja?
No further questions now, so we'll just have to wait for the XDB script to run.
Okay, so if I look at the console over here, we can see the operations performed by FieldView at the same time. So here, yeah, it has read the data, it has just computed the streamlines. And it must have already exported the image. If I go check, all right, this is the new XDB file that we have over here. Yeah, same size, but new date. So we created it in batch, and this is, yeah, webinar images over here. So that's the image we created in batch. Well, in batch. It was not a headless batch, but we created it interactively. And FieldView can be run in full batch in just the same way without the interface coming up with just a command line option. So all of that is fully documented. But here you go. This is really the initial stages for learning to do war scripting. You recommend that you do your work interactively, save a guide AVX, and then use those simple scripting commands for performing operations. All right, with that, I'll get back to you, Raja, for concluding this webinar.
Yeah, thank you so much, Marie. That was a lot of good information, and hopefully everyone found something valuable in there. Again, we'll send out the video link afterwards. If you don't have access to FieldView, please use this link to download a version of FieldView. And we are going to be at AIAA Aviation on June 28th to the 30th. Booth 409. So please, if you're going to be at the show, come by and see us. Again, if you want to do a deep dive, please let me know, and we can set up a more deep dive conversation for you. So with that, thank you, Marie, and thank you everyone for joining us today, and hope you have a great rest of your day. Thank you.
Yes, thank you, Raja, and thank you everyone for joining us. We appreciate your time.